In this video, we'll be looking at how to solve a system of linear equations using a method called substitution. Now, I've seen this method a lot in more advanced math and in science, so hopefully you'll get a good grasp of it today. Alright, so let's look at an example. So in my example, I would like you to solve this system of equations. The first equation is y equals 6x minus 11. And the second equation is negative 2x minus 3y is equal to negative 7. So this is just an example here. All right, so as the name suggests, it's all about substitution. You're going to take something, just think of it like a game, like a basketball game. You know, somebody's tired, they need to sit out the game, and so they sit and a replacement goes in for them. So in this case, well, in this we have an x right here and we have a y right here. So let me actually use just a pointer instead. We have an x and we have a y. And that's a problem. We have an x and we have a y. It's a problem to have both an x and a y in both equations. We can't have different guys in the same equation. So what we can do instead is, since y is also 6x minus 11, we can take that 6x minus 11 and sub it in for that y value. So instead of putting y here, I'm going to take that out and I'm going to sub in 6 minus 11 for that y. So then we would get, let's call this equation 2, and let's call this equation 1 so we can keep track here. So my second equation, my equation 2 now becomes negative 2x minus 3 times y, but remember, we're no longer calling y, we're subbing in 6x minus 11, so that's our new y, equals negative 7. This is still equation 2, but we've taken out that y and we've put 6x minus 11 in its place. Now we can distribute, and we get that negative 2x minus 18x plus 33 is equal to negative 7. All right, cool. So now we are able to join like terms here, and we get that negative 20x plus 33 equals negative 7. So we're isolating the x, and we just do that one step at a time. We can take 33 from both sides, and we get that negative 20x is equal to negative 40. And now we can divide both sides by negative 20, and we get that x is equal to 2. This is a negative 20. All right, but we're not done, because we found out what x is, and even though we subbed out the y, there was still a y in our original equations. So now we can figure out what y is by choosing either equation 1 or equation 2 and putting our x value in. So let's go ahead and do that. So I'm going to choose the easier looking equation. I'm going to choose equation 1, which said that y was equal to 6x minus 11. Okay, so y is 6, and we now know that x is 2. So I'm going to take that 2 and stick it in here for x minus 11. So y is equal to 12 minus 11. Y, therefore, is equal to 1. So now we know that x is equal to 2 and y is equal to 1. Let's try another one. Okay, so we just learned that we can substitute something in for our y. Or in the same way, we can actually substitute something in for our x. But we have a little problem here, because in this case, we don't have an expression equal to y or x. But that's easily fixed. So what we're going to do here, Because we don't have x by itself or y by itself, well, we've got those skills needed to put x or y by itself. So that's what we're going to start off with. And it would be easier, let's number these equations. It would be easier to do it with equation 2 because x is almost by itself. We just have to do one thing to get it by itself. So let's add 2y to both sides. And now we have x is equal to 11 plus 2y. So now this is something that we can take and substitute into our other equation for x. So let's see how that will work. So I'm going to write down equation 1, which was negative 7x minus 2y equals negative 13. I haven't done anything with that equation yet. I just rewrote it. So we have two different variables in that equation. We have x, we have y. And that's an issue. We don't want two variables. We only want one. So we can now, since we have this expression for x, we can take it and we can sub that in for our x. So I'm going to take that and I'm going to stick that into the equation where x is. And we have negative 7 times 11 plus 2y. Again, that 11 plus 2y is just x. It's just another way of saying x. Minus 2y equals negative 13. All right, now that we have that, we can go ahead and simplify. So we can distribute our negative 7, and we get negative 77 minus 14y minus 2y equals negative 13. So now we can join our like terms, and we get negative 77 minus 16y equals negative 13. All right, so we are almost there. Let's add 77 to both sides, and we'll get that negative 16 is equal to 64. Sorry, negative 16y. That's kind of important. All right, so now we can divide both sides by negative 16, and we get that y is equal to negative 4. So that's one of our solutions. So now, as we did in our previous example, we can take that solution and plug into either equation. And since that equation looked a little easier, which is also the same as that equation, we can use either one of these. We can use any one of these equations at the top. All right, so I choose to use that x equals 11 plus 2y. X equals, therefore, 11 plus 2 times negative 4. Where did I get this negative 4? That's right, from there. Which means that x is equal to 11 minus 8. So we know now that x is equal to 3.